Right, welcome back. Here we are starting chapter 5. Chapter 5, we are going to be doing some more graphing. So that's why we reviewed graphing yesterday. And remember, when you graph a linear equation, a line, that line represents all the solutions to that equation. Sometimes we plot a couple points to draw the line, or we use slope and y-intercept. But when we draw that line with the arrows at the end, that means every single point on that line, even all the little decimals and fractions, are all solutions to that equation. Well, what we're going to be doing in chapter 5 is we're going to be doubling the fun, because we're going to be graphing two lines on the same coordinate plane. And what we're interested is seeing where these lines intersect. So notice on this first graph here, when you graph two lines, most of the time what happens is you get that point of intersection. And that point of intersection is a common solution to the two different equations. Because that point is on both lines, it's a solution to both equations. So it's pretty cool. We found an ordered pair that is true for both equations. So most of the time, this is what's going to happen. And what we're doing today for the lesson, this is always what's going to happen. But it's interesting to consider what other possible things could happen. So most of the time, again, you get one solution, okay? One ordered pair, x, y, that's a solution to both equations. But you could get no solution. That is, if the lines are parallel and they do not intersect, then there's no common solution, and there's no solution that's true for both equations. The other thing that could happen is you get the same line. You know, it's kind of like maybe you have x plus y equals 4, and you have 2x plus 2y equals 8. Notice the second equation is the first equation times 2. So it's really the same equation. And so when you get the same equation, you have infinitely many solutions, because every single point on that line is a solution to both. But again, we're focusing on finding that common solution, that point of intersection. Well, just to get us warmed up and to see how you could check your answers, they're going to start with something like this. They're going to give you an XY ordered pair, and they want to know, is that a solution for both of these equations? So what we're going to do is we're going to plug them into each of them and see if they're true. And this is how we could check our answer. Negative 3 plus 1, does that equal negative 2? Yes, it does. What about negative 3 plus 5 times 1? Does that equal 2? Yeah, well, negative 3 plus 5 does equal 2, so checks. So the answer here is yes, because both equations were true when we plugged them in. You try this one now. You can pause the video and then restart it. We're going to plug in 5 for x and 2 for y. And let's see, that's going to give us 10 minus 6 equals 4. We know that's true. How about the second one? 2 times 5 plus 8 times 2. That's going to give us 10 plus 16. Ooh, that equals 26, which does not equal 11, right? So that is no then, because it has to be true for both to be a solution to both equations. All right, so what we're going to do right now is we are going to find that solution by graphing both equations and seeing, we're going to look for this point of intersection. We want to identify that. And then once we find it, we can check it by plugging them back into our original equations just to confirm. So when we do this, obviously then we got to be really careful how we're graphing. We want to use rulers and be as accurate as possible so that we find that common solution. So, and so for this, for the homework, I will probably make hard copies because it's better to use the ruler. It's a lot easier than doing it on the iPad. Also, if you are using an iPad or something, I'm going to make lots of points like we've done before to make sure my graph is as accurate as possible. Okay, so y equals negative 2x plus 5. Remember, that means that the slope is negative 2, or negative 2 over 1, and our y-intercept is 5. So we're going to start at 5, and we're going to go down 2 over 1, down 2 over 1, down 2 over 1, and so forth. Like I said, since I can't use a ruler on here, I'm going to make lots, oops, oh, that was right. I'm going to make lots of points. And then I'm going to try to draw the best line possible. And there we go. So that's this first one. For the next graph, I'm going to use a different color. That one has a slope of 1, or 1 over 1, and a y-intercept of negative 1. So negative 1. I'm going to go up 1 over 1, up 1 over 1. Oh, I think we can see our point of intersection here, right? By making lots of points, we are assured of finding that point of intersection. And so now we can see that point right there. We need to identify it. Okay, so our solution is 2, 1. That is our answer. Oh, I'm going to put it right here where it wants it. And if we wanted to check it, right? If you want to check it, we would plug in and we would say 1 equals negative 2 times 2 plus 5. Negative 4 plus 5 does equal 1. So that checks out. And then let's see, 1 equals 2 minus 1. Check. So you don't have to check it, but I wanted to demonstrate how you would check it so that on a quiz or a test, you could check your answer. All right, let's do this first one in pink. Now you're going to try this one. So negative 3 is my y-intercept, down 2 over 1. If you're watching the video, you might have wanted to freeze it, pause it, see if you can do it on your own. This is a try. And then for my other one, let's use a different color. That has a y-intercept of 4, and that's going to be up 3 over 2. Uh-oh, I can't go any more. Well, I could go there, but now I can go opposite ways. Oop, there we go. I think I found my point of intersection. And my solution is negative 2, 1. Again, if you want to check it, you could plug it back in to each of these, right? Like 1 equals negative 2 times negative 2 minus 3. 4 minus 3 does equal 1. Okay, so you could plug them back in to check. You know what? I'm going to check the other one as well since it's a fraction. So when we simplify this, we're left with negative 1. So negative 3 plus 4 is 1, so that checks out as well. All right, let's try this one. Ooh, it's not the way I want it to look. I want it to be y equals. All right, so let's take this first equation and let's solve it for y. Let's move that 2x to the other side. So now it says y equals negative 2x minus 4. Now it's the way I want it, so I can graph it. So negative 4 is my y-intercept. Oh my goodness, we had a lot of slopes of negative 2, didn't we? Interesting. And so now I'm going to draw that. Now, my other equation, y equals 4. Remember what that looks like? Y equals 4, remember, is that horizontal line that's going to go through 4 on the y-axis, which means this point right here is my solution. So negative 4, 4. And there we go. This one, we got to do a little bit of work again. So let's see, 2y equals 6x plus 8. We're going to have to divide everything by 2 to get y by itself. So y equals 3x plus 4. So 4 up 3 over 1, up 3 over 1. We're going to go the other direction as well. And draw our line. There we go. And for this next one, same thing, we got to do some work. So 4x plus y equals -3. We're going to subtract 4x from both sides, and we get y equals -4x minus 3. Don't forget, whatever's in front stays in front. So we'll start at -3, 2, 3, 4, down 4 over 1, 2, 3, 4, up 4 over 1. In the opposite directions, obviously. And it looks like right here, -1, 1 is my common solution. Again, you can always plug in that common solution back into your original equations to make sure that it checks out. Finally, we have one for you to try. So pause the video and try it on your own if you want. First, we need to put it in slope-intercept form first. Now we're going to divide everything by 2. So it looks like we get y equals -1/2 x plus 4. So we're going to start at 4, down 1 over 2. And we'll go the other direction. And that gives us that. Now for my other graph, we're going to do 3x minus y equals 3. Ooh, this one's a little tricky when we solve it. Notice that negative is still in front of the y. And so now we're going to divide everything by -1, which is going to give us y equals +3x minus 3. So here, now we're going to go up 3 over 1, up 3 over 1. So things to keep in mind, if it does not cross at a nice place, you probably messed up somewhere. Okay, so if it doesn't cross at a nice ordered pair like this is 2, 3, then you need to start over, see where you went wrong. Most likely it was when you put the equation in slope-intercept form. So just go back, retrace your steps, make sure you didn't mess up a negative sign. Also make sure you graphed it properly. So that's it. Today, it's very visual. We can see that we're going to graph the two equations on a coordinate plane. We are looking for that point of intersection. Once you find that point of intersection and you write your ordered pair, if you wanted to check it, you could check your answer by plugging your answer back in to both of the original equations to make sure they're true. Good luck.